Welcome and hello. This is a tutorial video on ResSim, and in this lesson, I'm going to talk about adding a power plant and adding a pump to a dam, and a dam is part of a reservoir. What I have on the screen here is a completed network. It's a simple network, just a single stream with a few reaches and a reservoir. So we're going to go ahead and make edits to this reservoir. At the top, I'm in the Reservoir Network module. I've created a configuration and then created a network based on that configuration. Go ahead and click the pointer tool or the reservoir tool. Either way is fine. Right click on the reservoir and then click Edit Reservoir Properties. This brings up our Reservoir Properties Editor box. All right, so the reservoir selected at the top here. We have the physical tab, that's what we'll be working in here. And we have our one reservoir here in the reservoir tree. We have a pool and a dam that are defined by default. I'm just going to call the dam instead of whatever it said. And then, yeah, we're ready to add our power plant. So we can right click and add a power plant. We could also just come up the dam and click add power plant, same thing. And instead of just adding a power plant by itself, we could add a power plant to a outlet group. So we could create an outlet group here and then right click, add a power plant. Because an outlet group could have other outlets like controlled outlets or uncontrolled outlets. And then those outlets could be controlled based on the group, not the individual element. So let's go ahead and do that. I'll delete that first power plant, and we'll be making edits to this power plant, which is inside the outlet group. I'll click on power plant, and over to the right, we have power plant data that's separated into different tabs: outlet capacity, efficiency, station use, and hydraulic losses. So I'll discuss these real quick. If you saw the previous video about controlled outlets, power plant outlet tab is the same thing as the controlled outlet tools. So we define the maximum capacity of the power plant based on the elevation. So you could type those numbers in, or you can paste them in from an outside source like Excel, and then you get a resulting release curve based on the elevation. If you had multiple gates, you can type in a different number besides one, like 2, and then the max capacity doubles. If I typed in 3, the max capacity triples. And as was the case with the controlled outlet, the power plant also has the ability to open gates a fraction of the way. So if I clicked on Edit Gate Settings down here on the bottom right, and instead of using this either completely open or completely closed setting, I could specify the amount that the gate is open, cranks they're called, either based on a percentage or the length that the gate is open. So for instance, if I had 5 settings and the first one is just 0, and the last one is 100%, then I have to move my dialog box here. Then the table gets a little bit more involved, where not only does the capacity or the flow rate through the power plant depend on the elevation, but also the percent that the gate is open. So let me just paste in some numbers real quick to show you what that would look like. It results in a colorful diagram here on the right, a thumbnail display showing flow rate, and for each elevation, where each color represents a different percent open. All right, and at the bottom here, there are a couple inputs for the speed that the gate can open. Those are recommended to be left blank and controlled in the operations tools. The next tab over is capacity. The capacity tab allows the user to specify the capacity of the power generation in the power plant. So if you want to just type in the installed capacity of 20 megawatts, then there's a few different ways to define the variable capacity. The default one is just installed capacity with overload factor. So if you're running the power plant at the installed capacity, you just put a 1 here. But if it was running at, say, 10% over the installed capacity, you type in a 1.1. That's how that works. There are a few other options here, like the function of reservoir elevation. What this looks like is The capacity of the power plant would be based on the elevation in the reservoir, the water surface elevation in the reservoir pool. Again, you can type in numbers or you can just paste them in. So it might look something like this, which means that the power generation is a function of the head loss. The next tab is the efficiency tab. This refers to how efficient the power plant is. Hydroelectric power plants are very efficient, somewhere between 85% and 95%. Typically, you could just type in a number, 90%. And if you want it to be a little more precise, there are options here to specify the efficiency based on reservoir elevation, the release, or the operating head. So in the case of elevation, I'm just going to paste in some numbers here. And sure enough, typically the higher the elevation, the higher the efficiency, or the higher the flow rate, the higher the efficiency. But every power plant's a little bit different. All right, a couple more tabs here. The station use refers to the amount of energy that's generated, used to run the station, not actually generated for the grid. However, it's defined in a function in units of CFS. So we're defining amount of energy based on flow rate. And this is typically 1 or 2% or even less for large power plants. And it's based on flow rate. So if the flow rate is, say, for example, say we only had one gate and it's, say, 2000, then 1% of that would be 200. I'm sorry, 20. So we could just type in a 20 here. And I'm not really fond of using constant methods. So there's also a function of release, in which case we would type in some flow rates based on the release. And I'm only going to use two points to define the curve here, which comes out to about 1% or 1.3%. The last tab is hydraulic loss, and this refers to the hydraulic loss in power between the upstream water surface elevation in the reservoir pool and the downstream tailwater elevation. And there will be naturally losses through the penstock and the power plant itself, but they will be typically pretty low. I'm just going to type in 5 feet. So that's what that is. Once all these changes are made, click apply before moving to the next tab, uh, or before exiting the power plant editor. Next up, we can create a pump. This refers to pumping water from the tailwater back up into the reservoir pool, typically happening at night when electrical prices are less. We can also add a tailwater elevation, which is not uncommon with regard to pumps, and defining that. Oops. So we click on pump, we can add the number of pumps. This pump here just represents a pump station, so we may just want to rename it as pump station A. There could be 3 pumps in pump station A. And if we did that, we put a 3 here, and we define the tailwater elevation and the max head. I'll just make them all the same, but they can be different. What has to be the same is the flow rate. So if it's a constant value, you can just type it in, or what's more realistic is to define the pump curve itself. So here are some numbers I just made up to show a pump curve. So we have 3 pumps, this pump curve. We could also have a different pump station group. We can call that pump station B. And maybe this has 2 pumps, and we could define those operating limits as well as a pump curve for those 2 other pumps. Even if pump station A and B are in the same location, they need to be separate if there's different pump curves. So in this video, we added a pump station and power plant to an outlet group, which was part of a dam, which was part of a reservoir. And that's one of the main components to working with and understanding HEC ResSim.